Right, so how do we answer this one? There are actually two ways of answering this question. You could do it by amortization, but just sort of reading through the markers notes and what kind of what they're looking for, I actually don't think that is probably a good idea. So let's let's do this now. So we only want to really stay on the calculator, and the marking sheet just says you don't really need to show it, you just need to show what you entered into the calculator. These problems are like notoriously difficult to do at the best of times, and doing it by hand would just be pretty awful. So you're going to use the TMV compound interest function on your calculator. That's probably what I'd say is just stick with that one. Okay, so there are seven things that we need to know. There are seven some settings that we need to know. The first one is N, and that's the number of payments. Okay. The next one is I, which is the interest rate. Now, your calculator does it automatically at 4.2%, so don't put 0.042, which is what your calculator will be doing automatically in the background. The next thing we need is the present value, and the present value for this is going to be 50,000. Now, it's going to be a positive number because that's something that she gets. So the convention is if it comes into your pocket, it's plus. If it's leaving your pocket, it's negative. Okay, so the present value is going to be 50,000. So that's how much you get right now. And you want to make it so the future value of that future value, we want it to be equal to zero. We want to pay it off. Okay. Um, so the next thing is going to be payments. So that's basically how much we pay, and we don't know that, and that's actually what we want to work out. The other ones that you're going to need to enter, but let's bring the calculator up so you can see. So we're going to go to TVM, time value of money, F2 or compound interest. So N is going to be the number of times you pay, interest rate, present value, payments, we don't know. The future value is going to be zero. PY is payments per year, and CY is a number of times it's calculated. So the interest is calculated. So what it's going to do, it's going to take that 4.2% and divide it by 12, and that's the amount that it's going to charge each month. So the interest rate, the headline interest rate is always going to be annually, but then your calculator is going to convert it to monthly. Okay, so payments per year is going to be 12, which I guess you don't really actually need to worry about for this one because it's already calculated, but it's calculated yearly, it's calculated monthly, so that's going to be 12. You could say that it's compounded annually over 300 years, and you would get the same. No, you wouldn't actually. You would get something slightly different. Yeah, but yeah, as long as they're set, just leave them as they are. So let's just put them. Let's just put them in. So the number of payments is 25 years times 12 payments. It's going to be 300 payments. The interest rate is 4.2% per year. The present value is going to be positive 50,000. Payments, we don't know. Future value, we don't know, and I'm going to actually enter it. So now that it's all entered, we're going to get these options at the bottom, and it's going to give us the amount, but I don't want to sort of go there. We want payment PMT, and it's going to be that 269.47. Now, some calculators will give you a slightly different number. It's because they round it slightly different. Some calculators only look at the cents and then sort of calculate it, and the Casio calculators look at this 11589 and work those in as well. So they're going to get a slightly different answer, but the markers know this. So as long as you put what's in the calculator, you're fine. So the answer for 1 is 269.47, and you have to have that as a positive number, even though it's given to you as a negative number, because you can't pay negative money, and you also have to have it only to 2 decimal places, even though the calculator will work out those other places. So the calculator will give an answer of negative 269. So remember, the convention is the fact that it's a negative number just means it's a payment that you are making. It's not, if it was a positive number, it would be the amount that the bank is paying you, which doesn't make any sense. Pay off a loan, you don't get more payments. You just pay from when you get it. Okay. So the second part B here, is she wins the lottery and pays back the remainder of the loan early in one single payment. How are we going to do that? Well, we're going to treat it as if she has a loan. We're going to say she has a loan for the remaining 17 years. So the number of payments is going to be 17 times 12. And the payments now, we know how much it's going to be. We're going to enter that, and it's going to be minus 269, 47. Okay. And then we're going to take it from there. So payments a year is going to be the same. The future value is going to be future value. I think it's going to be the same. So we're going to work it out from there. So here's how we're going to do this one. So we're going to exit out of there. Now the number of payments that have been made, we need to work it out. So we need to work out how many are left. And there's going to be 17 times 12 remaining. It's going to be 204. Okay, the interest rate is the same. Now, the present value, we don't know. All right, so we're going to set that equal to 0, and we want to solve that. And the payments are going to be the same. The number of times it's compounded is going to be the same. But now we want to know the present value, what that, if we took out a loan with just 17 years, paying that much, what would the loan's present value be? If we hit F3, it's going to be 39,243.28, which is a little bit different from the Hewlett Packard and Texas Instruments calculators, but we'll go with this one because it's what's given, and it's going to be what most students are going to have anyway. So it's going to be 29 in euros and euro cents. Okay, so that's how much you would pay in as one lump sum if you won the lottery. Now part 2 is actually a little bit easier than you think. So we're just going to work out how much we pay out. So scenario 1 is if we paid everything over 300 payments of this 249.47. So this is going to be 300 times $269.47. 47. So that's how much we're going to pay out. The second one, scenario 2, is when we win the lottery. So it's going to be this amount here, which is 243.29. So even though you win the lottery, you're still going to pay that. Plus, and now it's going to be, so how many payments did we make before we won the lottery? And that's going to be, yes, was it? Was end of 8 years. 8 years times 12 months times the 269.47 number. And then we're going to find the difference. So we don't even need TVM now. We can just use the regular calculation screen. So the first one is going to be 300 times 269.47. So 80,841 euros. So kind of shocking. We took out a loan for 50,000 euros, but we actually end up paying that amount, and it's going to be exact like stuff. Okay, scenario 2 is going to be all of that added up. So it's going to be 39,243.29. That's the payment that we have to make, plus 8 times 12 times 269.47, close brackets, and it's 65,112.41. So 65,112 and 41 euro cents. So what's the difference? The amount we saved is going to be that 80,841 minus 65,112.41, and it's going to be some number. So 80,841 should be a 1 there. Minus 65,112.41, 15,728 and 59 cents. So our end total is 15,728 and 59 euro cents. And that's the answer to B2. So stick to that. There is an option of using another function called the amortization, which is one which is done especially for loans, and it kind of copies the numbers through for you. My advice is kind of leave it. If the compound interest does everything, then stick with the compound interest screen.